Hello students, in this video I'll discuss the second part of the matrix. In last part I discussed about the transpose, about the symmetric, skew symmetric matrices or orthogonal matrices. Now in this video I'll discuss the very few topics. The first one is adjoint of the matrix, number 2 inverse of the matrix. Now before I proceed with the adjoint, I just want to take you to a small tool in determinants. In class 12, you have a third order determinants. Like suppose it is there 1, 7, 6, 5, 2, 3, 4, 1, 0. And if you want, suppose this is a determinant A. Determinant is represented under the two bars. Now, if you want to find the value of A, that is, if you want to find the determinant of A, then there is a value assigned to this determinant. Now, let us learn how to expand this. There is a invisible pattern of plus minus sign inside this determinant, like this one. For the first element, it's a plus, then minus, then plus, then minus, then plus, then minus, then plus, then minus, then plus. It's an alternative arrangement of plus minus sign. Now you can expand this determinant along any row, particular row or any particular column. It will be your own choice whether you want to expand along row 1, row 2 or row 3 or column 1, column 2 or column 3. But whatever be the row or column we will take, we must take into account these sign patterns. So for convenience, I would advise that we will always prefer either a row 1 or either row 1 or the column 1. So if I expand through this using that is a row 1, the value will be that is a 1. If I delete the one column and the row containing 1, whatever I left with is 2, 3, 1, 0. If I remove these two, I'll get 2, 3, 1, 0. Plus sign, then minus of 7. And if I delete the row and the column containing 7, it's a 7. I left with 5, 3, 4, 0. Last sign plus 6. And if I delete the row and column containing the element 6, it's 5, 2, 4, 1. So if I evaluate again, this is 1. 2 first will go like this, then minus this, like we have done in the cross multiplication. So it's a 0 minus 3 minus 7 into 0 minus 12 plus 6 into 5 minus 8. So it's minus 3 plus 84, 5 minus 8 minus 3 minus 18. So it's 84 minus 21, which is 63. So this is the value of this determinant. So hope you understand how to expand a determinant of any third order. Whatever be the row or column you will take, the answer will always come 63. Now, after this, let us understand the concept of minor and cofactors. Minor and cofactors in a determinant. Minor and cofactor. Suppose I am taking a determinant like this 1, 7, 6, 2, 3, 4, 1, 8, 9. So corresponds to each element in this determinant, there exists a minor, and which is obtained by the deleting the row and the column containing that particular element. Suppose if I choose this one 1, so if I omit this, we left with 3, 4, 8, 9. Then 3, 4, 8, 9 is known as the minor, which is generally represented by A11, capital A11. Or if you want, you can let us take M1 minor. First row, first element M11 is 3, 4, 8, 9. Similarly, if you want to find the minor of this, which is the second row and the second column, that is M22, It is obtained by deleting the row containing 3 and the column containing 3. And if I do so, I left with 1, 6, 1, 9. So 1, 6, 1, 9. And if you evaluate this, this is 27 minus 32, which is minus 5. And this is 9 minus 6, which is 3. So this is the minor. Minor with those invisible pattern sign. Minor with signs are known as the cofactor. Suppose, so it is plus, minus, plus, minus, plus, minus, plus, minus, plus. So it is M11. Only minus 5 is minor. But if I put this along with this plus sign, this complete quantity is known as cofactor now. M22, though it is 3, if I put here 3, this plus 3 is the complete cofactor. So minor with cofactors is known as the, minor with sign is known as the cofactors. So you must keep in your mind while understanding the adjoint and inverse. So it's just a very small knowledge which I want to give you before I proceed with the adjoint. Now, what is adjoint? Suppose there is a matrix A. Elements are 1, 6, 3, 4, 5, 8, 2, 3, 9. Okay? So, this is the matrix A. The adjoint of the matrix A is denoted by the letter adjoint of A, ADJA, or the adjugate of A. The adjugate of A is the matrix of its cofactor and then transposing it. Mark my word, adjoint of the matrix is the transpose of the matrix of their cofactors. Is the transpose of the matrix of their cofactors. So, since you should not make any mistake, I'll suggest you how to find the adjoint, because this is the area where students can do the maximum mistakes. They every time they come up with a sign mistake in this. So to avoid this, what I suggest, put two capital braces like this. You put initially your sign, that is the alternative arrangement of plus minus, so that you cannot forget these signs later on. After this, put the T here. This is the full format of finding the adjoint. Now you don't have to take care of the sign every time. Forget about the sign, just find the minor from this matrix and put it there. So for this one, the corresponding minor will be, I will write here in the first row, first column position. So what is the minor of 1? Deleting this, 9, 5, 45, 45 minus 24 is 45 minus 24 is 21. So this is this. 6, 9, 4, 36, 8 to 16, 6, 36 minus 16 is 20 minus 20. Then 3, 4, 3, 12, 12 minus 10 is 2. Then 4, if I do it, 9, 6, 54, 54 minus 9 is 45, so minus 45. Then 5, 9 minus 6 is 3. Then this 8, 8 will be 3 minus 12, that is minus 9. Then 2, 48 minus 15, that is 33. Then 3, 8 minus 12, that is minus 4. Then last 9, 5 minus 24 is minus 19. And if you transpose this, because you have to transpose it, so transpose will be 21 minus 45, 33, then minus 20, then 3, minus 9, then 33, then minus 4, 23 minus 4, then 2, minus 9, and minus 19. So this is the adjoint of the matrix A. So adjoint, this is the way how you can find the adjoint. Now, what is the inverse? A inverse equals to adjoint of A by determinant of. Now we can discuss something about this formula. This means if the determinant of the matrix is 0, inverse cannot exist as the determinant of A is in the denominator. So this you need to keep in your mind while evaluating this. First, while evaluating the inverse, first find the determinant. If the determinant is 0, just write inverse do not exist. But if inverse determinant exists, then we'll proceed and we'll find the adjoint of A. So for this one, to find the A inverse of this, I have the adjoint. What I need to find? Only the determinant of A. The determinant of A, the value I will find here is along the first, this row is 1 into 21 minus 6 into minus 20 and then plus 2 into 2 plus 3 into 2. So this is 21 plus 120 plus 6, that is 147. So A inverse, if I write here, A inverse is adjoint of A divided by determinant of A, which is 147. And this is how you find the inverse of a given matrix. Now this inverse of a given matrix is very much important while solving the matrix equations. That is by solving the equations in 3 variables using Martin's rule. So this is how you find the A inverse. Now, one formula you should keep in your mind. Sometimes a 1 mark sum or the 2 mark sum may come from that. That is, determinant of the adjoint of A is the determinant of A to the power n minus 1, where n belongs to natural number and is called the order of the matrix. And is called the order of the matrix. That is, adjoint of A, determinant of adjoint of A equals to determinant of A to the power n minus 1. This you must keep in your mind. Now next topic is the Martin's rule, which is the exact and the direct application of the inverse. Martin's rule. Martin's rule is used to find the solution to the equation in 3 variables x, y, and z. Like we have solved in class 9 that solution of system of linear equations in 2 variables, simultaneous equations. Here you have the equations in 3 variables. Let us generalize the 3 equations as a1x plus b1y plus c1z equals to d1, a2x plus b2y plus c2z equals to d2, a3x plus b3y plus c3z equals to d3. What we will do, we will put them into a matrix. We make a 3 matrix. The matrix A, which is the we know as coefficient matrix. Coefficient matrix. Coefficient matrix is the matrix obtained by taking the coefficients of x, y, and z respectively. Then there will be an X matrix, that is a variable matrix. Variables matrix, that is x, y, and z. There is a matrix B, which is the constant matrix. Variables constants matrix, that is D1, D2, D3. Now, as you know the multiplication, I am making 3 matrix A. The matrix A as A1, B1, C1, A2, B2, C2, A3, B3, C3. This is the matrix A. Matrix X is as I said, it's a variables matrix. It is X, Y, Z. Now order of A is 3 cross 3, whereas order of X is 3 cross 1. So it is confirmable for matrix multiplication, as the number of columns in A equals the number of rows in B. So if I multiply this one, see what I will get: A1X plus B1Y plus C1Z. That is this matrix. And the B matrix is B1, B2, B3. So AX. So our final equation, if I put them into a matrix form, so my equation stands on AX equals to B. Because if I multiply A with X, I'll get this expression. And if I equate it to B, so with the equality of matrix, we can equate the corresponding rows. So first row will be equals to D1. I think it's quite obvious. So now how to find this? Now I am multiplying both sides by A inverse. As I know A into A inverse is I, so X is equal to A inverse B. X equals to A inverse B. Now how to find the solution? First you will find A inverse. Whatever the matrix A inverse you will get, multiply with the B matrix, which is quite confirmable for the matrix multiplication. And finally, when you equate, this will be X, Y, Z. This will also be a 3 cross 1 matrix, and you can compare, you'll get the value of X, Y, and Z. This is the way by which you can do the Martin's, apply the Martin's rule, and it's a direct application of the A inverse. Now, after this, there is some small part regarding the inconsistency and the inconsistency of the system that I will discuss in my later videos. Till then, you should practice the sum up to this from your exercise book and come up with the doubts. If you have any doubts, then put up in my comment section. Till then, enjoy this and like my channel, subscribe my channel. Thank you so much.